So what we're doing here today is just a quick overview of some of the shape measures that are used for fibers. The Insight software has a tool called the shape test image, which is this screen that comes up, and the software will treat this one image as a real image. So we can actually do an analysis of all the particles on the screen with whatever settings are set and rejections or what have you. The thing I wanted to point out today was fiber analysis. So for fibers, if you use a system that assumes particles around as equivalent circular area diameter is doing here, you'll notice that we'll put a model around every fiber or every crystal shape. And in some cases, a 13 micron particle, 14 micron particle, this is about a 13 micron particle, this is about a 12. You can obviously tell that using a model that a particle is round is a bit misleading when it comes to analysis of fibers. When it comes to fibers, some of the better measures to use are things such as bounding rectangle measurements, where you can get aspect ratios, which are a lot more relevant for fibers. You could also look at length, width, and aspect ratios. There are also foray measurements, and there's also fiber measurements. So we can actually take a fiber that might be curved, and we can actually tell you, for example, what the width of that fiber is. When we straighten it out, we'll straighten it out and tell you what the length is. And we can also tell you what the aspect ratio is as well. So some of these fibers, as you can see, have a very, very long, very high aspect ratio. Again, these are the measures that are very useful when it comes to measuring fibers to be a little bit more accurate and more practical, I guess is the better word. Another image that we're going to show you is actually a very interesting particle. It's somewhat curved. It's a particle that is called spirulina. So spirulina, if I open up here, it's a dietary supplement, basically. But when you actually look at the zoomed in images of spirulina, you could tell they're a bit curved. I could actually zoom in a little bit and show you what it's like, and you'll see some that are actually very curved. When you see the curved images, again, this is they're very small. We can actually, let's do an actual fiber curl in this case. So fiber curl is actually a very interesting measure. Fiber curl will actually tell you what the amount of curvature there is on every fiber. So basically, if we zoom back out and we could hit analyze, we could see the curvature of every fiber. Well, this is aspect ratio. Sorry, let's go to fiber curl. So, for example, when you get a fiber that's very curved, it'll be further away from 1. When they're less curved, for example, for this one down here, when they're more curved, sorry, there'll be a much lower number. So again, fiber curl, very useful when you're working with fibers such as the spirulina. Zoom in a little bit. Where you'll see a straight particle might give you something like a 0.91, closer to 1, but as the particles become less and less straight, they'll go away. What's really useful for this is to be, with this measurement, is to be able to determine, for example, in this case, maybe the curved samples are the ones that are of more interest. We can actually do a look at the statistical histogram and be able to differentiate what percentage were curved and which ones were not curved. So that's a useful example.